first thing we always recommend is, in an existing building, do what you can to eliminate drafts and to insulate. That's absolutely the first thing that you should concentrate on. And if you're building a new home, don't skimp. Make sure that you invest and design around as much insulation as possible, and airtightness as well in a new home. So the best approach really is to look at the complete dwelling and understand all the energy requirements. So that typically is the big one is the heat demand, and important to calculate that. But also, you know, how are you going to use the building? What sort of lifestyle do you have? Are you somebody who's going to be able to install a wood boiler and load that every second morning in the winter and light it, or do you want something more convenient that is going to look after itself? And then we also need to look at the site. What does the site offer in terms of that we can tap into and harness in terms of renewable energy? Is there a south-facing elevation that we can look at for solar? Is it a very large piece of land where we could consider a small wind turbine 100 meters from the property? All these sort of things are really important to look at to get a complete picture before sort of deciding on the most appropriate solution. There are lots of things that can be done, and I'm just going to go through a few of these technologies very, very quickly. Ground source heat pumps, where we're harnessing stored solar energy in the ground or in the air or in water, and the earth acts like a battery that's charged with solar energy during the summer, and we can harness that and use that during the heating season during the winter. Different ways of harnessing the energy through a horizontal loop about a meter below the surface, or a borehole if there's not space for that. For a typical 3-bedroomed house, you need about 400 square meters for a horizontal loop, or 140 meters down in a borehole to provide the heat required. And a lot of people ask us, you know, how does a heat pump actually work? Because how can we get enough heat from the ground? And here it's all about 3 circuits really. So we have a circuit outside in the ground in the case of a ground source heat pump. We have a circuit inside the heat pump, which is a refrigeration cycle, and then a circuit inside the house, which is the heating distribution system, so underfloor heating or radiators. And the secret is that this is the circuit inside the heat pump. So we have heat coming from the ground, which might only be 0 degrees, but that's enough to make the refrigerant inside the heat pump evaporate, because it has a very, very low boiling point. So that's enough to change the refrigerant from a liquid to a gas, and as a gas it gets pumped through the compressor, and the temperature goes way up to 100 degrees before the gas delivers its heat in the condenser, transferring the heat to water, which is then usable for heating and hot water. And it's the same process with an air source heat pump, except instead of coming from the ground, we're tapping into stored heat in the air. This is an example of an air source heat pump which needs to be positioned outside. Ground source the actual unit can be inside the house. And this is an example of a project that we've done where we've retrofitted an air source heat pump into an old cottage. And this family were paying £200 a month for oil heating, and installed an air source heat pump over a year ago, and we've been monitoring the costs, and over the year they're now paying just £68 a month for heating and hot water. This photograph shows the unit inside the house, the outdoor part, the indoor part, which incorporates the hot water cylinder. For those of you building a new home, very important to consider heat recovery ventilation. As the building regs improve and we want to build more airtight houses, better insulated, so the importance of ventilation increases, because we must get moisture out of the property to avoid sick building syndrome, problems with moisture, dampness, which can lead to allergies and asthma and illnesses, etc. And it's something that the Scandinavians came across and dealt with 30 years ago, but only now are we building new homes to that sort of standard. So it's very, very important that you consider that. Solar thermal can work integrated into a heating system or for hot water, and can be providing free energy when the sun's shining, but can only really be considered as a secondary heating system along with a primary heating system. Biomass, wood pellet boilers, which provides a high temperature, so very good for retrofitting into an existing building where the insulation levels aren't as high, because we're still getting a high temperature which can go through an existing radiator system. Just to let you know, those of you who are considering replacing an oil boiler or an LPG boiler, for example, and you're off the gas grid, the government this week has just announced an extension of the renewable heat premium payment, which gives a grant of these amounts towards those different technologies. And it's a one-off payment. And then the government has also talked about a renewable heat incentive, which will be an annual payment, which we anticipate starting in the summer next year. But if you install now, and that happens in the summer next year, you'll still qualify for the ongoing payments. Solar thermal you can install even if you have a gas heating, but the other technologies you need to be off the gas grid. Solar PV has been very much in the news, a lot of awareness around that. The feed-in tariff rate has now dropped, but so has the price of solar modules, and we're even now with the lower feed-in tariff looking at a payback of around 10 years, with the feed-in tariff lasting 20 years. So this is all driven, the feed-in tariff, the renewable heat incentives and other initiatives like the Green Deal, which the government is planning to launch later this year, to encourage us to improve the energy efficiency of our homes. It's all driven by the UK and EU targets, improving energy efficiency, increasing the percentage of our total energy that comes from renewables. This is a chart of all the 27 EU member states and how much energy at the moment comes from renewables. And Sweden is the top performing country, as one might sort of expect, with about 44% at the moment, and their target is 49% for 2020. And as you see, you have to go way down to second from the bottom for the UK. I think we're on about 4% at the moment. Our target is 15%, so well short of the EU average. And we have one of the oldest housing stocks in Europe, so an awful lot to be done. So why should you consider installing renewables? Well, to become more self-sufficient and less exposed to increasing fuel prices. Also, this is the latest technology we're talking about and can improve the comfort levels inside your home. Obviously, reduce your carbon footprint, and importantly, reduce your running costs. And potentially create an income as well through things like the feed-in tariff and the renewable heat incentive. So potentially, going back to the original slide about typical energy use in the home, through draft proofing, insulation, and installing renewable heat, we can reduce that 25,000 kilowatts down to 10,000 kilowatt hours a year that we actually pay for. And then installing, for example, solar PV, we can reduce the 5,000 required for appliances and electrical usage down to, say, 3,000 in the average home, which gives us, instead of 30,000, the potential to reduce that way down to 13,000. So substantial savings possible. Just very quickly, this is a new build project that we've been involved with. And the figures are very different, the energy usage figures for a new build, where the insulation levels are much, much higher, and the air tightness. So we can get heating way down from 80% down to 34% of the total energy requirement. And it means that things like solar thermal can have a much bigger impact in the scheme of the total energy requirements. So here, for example, the actual running costs 3 years down the line in this house average about £883 a year for heating, hot water, and all energy requirements for the property. This customer has just installed 4 kilowatts of solar PV and plans to do another 4 kilowatts, which will potentially bring the total running cost down to £350 a year, which I think you agree is pretty impressive. So, very quick run through of a few of the options, but the key message is to look at the whole project, the whole house, the energy requirements, and work out, do your research, work out what the most appropriate solution for your particular situation is. We're exhibiting just round the corner here if you would like to catch up with us and ask us any more questions. Thank you.